Hello guys, so we are back. I am back with the corresponding proof of the variance of the betas. Okay, so what we have proved till now, we have proved very important identity that I have explained in the last video, the previous video, that covariance of y bar comma beta 1 hat is equal to 0. Now observe the very important identity over here. What is y bar? Y bar is this minus y bar is equal to y like x bar, sorry, I'm so sorry, beta naught hat plus x bar times beta 1 hat. So observe now very carefully that we'll do two equalities over here. So variance, so let's write it this in this format, is equal to beta naught hat. Okay, so this is beta naught hat. So now let's compute two things. Covariance of beta 1 hat comma beta naught hat is what? Is actually equal to covariance of beta 1 hat comma y bar minus x bar beta 1 hat. So we get that covariance of this is equal to 0 because y bar here is y, because you can write like this. Minus x bar covariance of beta 1 hat, beta 1 hat. We can write it as 0, we have proved it already, minus x bar times variance of beta 1 hat. Very good. So we have done this. Covariance of beta 1 hat times beta naught hat is equal to minus of x of variance of beta 1 hat. Now let's try to understand the variance of beta naught hat. Variance of beta naught hat is actually equal to what? It's actually equal to variance of y bar minus x bar beta 1 hat. It's actually equal to x bar square variance of beta 1 hat. Very good. So therefore we have sort of done a connection between the variance of beta naught hat with variance of beta 1 hat and the covariance of beta naught and beta 1 hat with the beta 1 hat, beta naught hat with the variance of beta 1 hat. So therefore we are only required to find now the variance of beta 1 hat. That's a very easy task. We'll do it right away. So let's go to the next slide. So we need to find variance of beta. My var is very bad. Yes. Variance of beta 1 hat. If we do that now, what do we get? We get that, observe, remember that summation of alpha I yi, alpha I equal to xi minus x bar by sxx. Now it's simple step. If you do variance of all the yi's are independent, remember that, because epsilons I are independent, therefore it's summation, therefore their covariance is 0, it will be therefore alpha I square variance of yi. Now the variance of yi is sigma square, right? Because epsilon I follow variance sigma square. And the xi is a constant. So it turns out it's summation of epsilon I square times sigma square. Sigma square, summation of, therefore put the square xi minus x bar whole square by sxx whole square. Now what is this? It's actually equal to sxx by sxx whole square. It turns out it's equal to sigma square by sxx. So what do we get? It's actually equal to sigma square by sx and x. Very good. So let's write down the results now. Variance of beta 1 hat is equal to, we have proved, sigma square by sxx. Variance of beta naught hat, we have proved what? It's actually equal to, remember what we have proved over here. It's my x bar time x bar whole square times variance of beta 1 hat. So x bar whole square times sigma square sxx. So this is this part over here. And covariance of beta naught hat and beta 1 hat is actually equal to what? It's actually equal to We have done this, so let's check it right away. It's minus x bar times variance of beta 1 hat. It's minus x bar times variance of beta 1 hat, that is sigma square by sxx. That's all the three results over here together. They're really beautiful. So yeah, so we are almost towards the end of this small series on simple linear regression. I will end this video here, but there's another surprise for you. We will do some R calculations and stuff to make you understand that what is actually beta naught and what is actually beta 1 hat and beta naught hat. That will be the next part of the last part of this series. Okay, stay tuned, stay blessed, and see you in the next video.